Okay, so moving on from our discussion on closures, let's continue our journey. Now, functions and methods are called callable because, well, they can be called. And this is why, in very simple terms, a decorator is a callable that returns a callable. Now, I've mentioned that a decorator takes in a function, adds some functionality to it, and then returns it. So let's see an example. Let's suppose we have a very simple function which we'll call original_func, and what this function will do is simply print out I am the original function. We can then create another function, and you may recognize this syntax. I'll give you a clue: think closures. So if we create a function called jazzUpTheFunction, and inside parentheses we pass in a parameter labelled func, which we will be expected to be populated by a function when this function is called, we can then put a colon. We are then going to define a nested function, so we can call this function inner. And what the inner function will do is firstly print to the screen, I'm adding this first. So you can see this as some form of added functionality. I will then call upon the function that is passed in as an argument to the outer function, and then I will finish by printing, I'll finish with this. And once again, just see this as some added functionality. Can you remember the final thing we need to do to make this a closure? Well, we need to return the nested function. So with these two functions defined, if I were to simply call the original_func function, you can see that we print to the screen, I am the original function. Now, if we wanted to jazz the original_func function up with the newly defined jazzUpTheFunction function, what we can do is create a variable, so create a name called jazzed_up, and we can set this equal to a call on the jazzUpTheFunction function and pass in the argument original_func, which is the name bound to that original function definition. So we are passing the original_func function into the jazzUpTheFunction function. If we take a look to see what type of object we're working with respect to jazzed_up, you can see that this is a function, and because this is a function, we know it's callable, so therefore if I put jazzed_up and put parentheses, when I run this code cell, we print I'm adding this first, I am the original function, followed by I'll finish with this. So what we've done is we've been able to add functionality to our original function by creating a closure and then creating a variable which equals a call on the outer function, in which we pass in the function that we want to have the additional functionality. So what bit of this is the decorator? Well, in this example, the jazzUpTheFunction function is the decorator. And what we would say here is that the original_func function is what has been decorated by this decorator, and the returned function was given the name jazzed_up. Now, an analogy that people often use to help them remember what decorator functions do is to think of wrapping up a present. Now, the decorator acts as the wrapping paper, but the object inside that got decorated, i.e. got wrapped up, doesn't alter. And that's the original function. The original function here is not being changed. But now, since we're able to call the jazzed_up object, which we know is that returned function, it looks a lot nicer since it's been decorated, since it's been wrapped up. And because this is quite a common need when working in programs, Python has syntax to simplify this. And the syntax we need to remember is the @ symbol. So we can use the @ symbol along with the name of the decorator function and simply place this above the definition of the function that we want to be decorated. So for example, if I put @jazzUpTheFunction, which is our decorator, and then underneath we put the definition of the function that we want decorated, so we can put def original_func and then simply print out I am the original function. This syntax is exactly the same as having the original _func function definition defined, and then assigning a name, in this example jazzed_up, equal to a call on the decorator where we pass in the original function. As I'm sure you'll agree, this syntax is a lot more simple, so rather than having to write this line here, we can simply use @ and then put the decorator name. This is what people refer to as syntactic sugar, which helps us implement decorators. In the next video, we're going to look at decorating functions that have parameters, which will be the final part of this section. So I'll see you in the next video.